You can take out one hazard, but are you increasing the presence of other hazards? What's better? What's worse? This is a judgment call that needs to be made on an engineering basis. Process safety requires constant vigilance. The challenge is when it works well, nothing goes wrong. People then question if you really need to spend all that money on safety efforts. The reason nothing is going wrong is because you're doing it right.
Process Safety with Trish and Traci is a production of Chemical Processing. Chemical Processing focuses on serving engineers, designing, and operating plants in the chemical industry.
Welcome to this edition of Process Safety with Trish and Traci, the podcast that aims to share insights from past incidents to help avoid future events. I'm Traci Purdom, Senior Digital Editor with Chemical Processing, and as always, I'm joined by Trish Karen, the Director of the iChemE Safety Center. Hey Trish, how are you?
I'm doing well, thanks, Traci. We're starting to now move into our spring, so the days are getting longer, the sun is shining, and the birds are singing, so it's actually quite pleasant. That's in between thunderstorms, but we take the good with the bad.
Absolutely. That sounds wonderful. We're heading into winter, so I will be living through you vicariously with your springtime stories, and hopefully I can hear some birds in the background this time.
Hopefully, and hopefully it's not too cold and snowy for you as you go into winter.
It's not. Well, we don't have any snow yet, and the leaves are beautiful, so I do like fall. So there are good parts to the fall, but the winter afterward is never fun. But I do like the first snow.
Yeah, we don't have a lot of the change in leaves over here because we don't have a lot of that sort of tree around our country and around the area I live. So we don't often get to see the magnificent colours that you do see with the fall leaves as they change.
I did not realize that.
Well, we have mostly gum trees. Gum trees are evergreen.
Well, I learned something new today. Well, let's actually get into process safety. How about that? For today's topic, we're going to delve a little bit deeper into a guidance document that iChemE recently released, applying process safety during the concept select phase of a project. What is concept select? Is it a wish list of options or a checklist that must be in the final project?
No, it's not a wish list, but it's that point in time at the very, very start when you actually get to think about what it is you want to build. So it's about trying to make the initial decision of, are we going to go down path A or path B, potentially, depending on what's going on. So an example here might be, if you were building an offshore platform, for example, what sort of platform might you choose to build? Will it be a manned platform or an unmanned platform? It's really that original decision. It might even be even further than that of, instead of a platform, will you just run a pipeline and bring everything on shore? Is another option as well. So it's really trying to go right back to the very beginning when you start to think of what your concepts could be and start to look at what might be a good decision from that point. So it's before you do front-end engineering, and it's certainly way before you do any detailed engineering. So it's right at that very start where you're looking at different options and you're trying to understand what those options could be, apply a high-level screening tool of some sort to that, to then select an option you're going to take forward for configuration. So then you put that option into your front-end engineering and design. So it's really this initial stage of, another example might be, I want to build a PVC manufacturing plant. Do I want suspension or emulsion technology? Because that will change what the plant looks like completely. It will change how you do it. You might even say at some point in time, if you're looking at building some form of integration into an existing plant, if you've got chemical streams, can you even potentially manufacture two different products from the chemical stream you've got coming in? So are you going to manufacture product X or product Y? It could even be that early in the stage as well. So it's this idea of blank sheet of paper. What do we actually want to do?
So is this the ultimate place to insert inherently safer design principles?
Look, I think it certainly is. It's certainly at the very beginning and the start. And the reason for that is you can tend to make some decisions in concept select that may aid process safety all the way through. So you could make a decision to build a particular type of facility from an unmanned perspective so that you are reducing the exposure of any personnel to the plant, for example, and except during maintenance activities, obviously. But so what you're doing is, how can we put process safety in right at the beginning? So questions might even be around where physically are we going to put this? Because separation distances is a part of process safety consideration and inherently safer design principles. So going right back to this stage and saying, where do we want to put it? How do we want to build it? How are we going to get product to it? These are some of the questions that actually do have a focus on process safety. Is the block of land big enough to build what you're trying to build and get appropriate separation distances so you're not likely to have domino effects in an incident, perhaps? So these are some of the sorts of questions you can ask at this point in time, and it's much cheaper to apply some of these thoughts at this point than get your block of land right beside the local kindergarten and then decide that it might be difficult to do something from a risk management point of view. So, if you make the decisions up front, then you might be able to get the right piece of land somewhere to do what you want to do with a large enough size. Once you're locked into certain design decisions as you go through the process, it becomes very difficult, if not at times impossible, to actually wind back some of them without completely starting again.
How do you know what questions to ask? Or basically, is this what the intent of the guidance document is for? But, is there something that you can look at to ask those questions? Or is it just experience where you have to think about those questions and you have someone in an experienced role to help you through?
That's partly why we wrote that document. It's really around what are some of the questions to consider. And in writing this document, we looked at a lot of the literature that had been written on inherently safer design and how it applies, and we looked at things that have been written on project management as well. So the CCPS book on applying process safety across project management covers all stages of a project. Excellent book. Certainly get hold of it, have a read of it. Great book. We've narrowed in on one particular section of the process and gone quite deep into that. And what we've done is also pulled together some documents from our member companies at the time of, here's how we do some of these things. And we've said, that's a good point. Okay, we'll start to put these things in it. And so first of all, if you start with the idea of in the inherently safer design principles, so you've got to start with elimination. Do we actually need to build this in the first place? It's an important question to ask. It's a groundbreaking question to ask, perhaps.
Literally.
Yeah. Substitution. What can we do differently? Minimization, moderation, and then simplification. And so what we've done is created several tables and checklists in this document that sort of say, okay, if we're going to talk elimination or substitution, you're looking at trying to avoid processing of toxic, flammable, or environmentally hazardous materials. So if we think about the chemistry perspective of it, then we think about, okay, so what are our feedstocks, what are our intermediates, our products, our byproducts, our impurities, incompatibility, toxicity, reactivity, radioactivity, etc. What are these things that we can deal with here? Can we eliminate or substitute any of them out at this point in time? And you can work through the checklist and look at various different elements of those different principles. But importantly, there's a couple of other things to be considered as well when you want to try and apply it at concept select stage. And so it's not just the inherently safer design principles that we're all used to talking about. We now also need to talk about things like the passive design and layout. So I said earlier, separation distances, operability, previous incident history for these types of facilities, including local, corporate and international, resourcing considerations. Can you actually get the resources to the facility that you need? That includes things like utilities and people. Reliability, availability and maintainability. And then lastly, the life cycle and end-of-life aspect of the project as well. So you can start to factor some of these things in. So you'd start to look at things like integrity of the containment systems that you're looking at. An inherently safer design principle that's been applied for the offshore industry, for example, is this concept of walk to work. So that's where you have bridge-linked platforms that are the accommodation decks that are different to the processing decks. They're completely separate, and you walk the work. What that does is it can allow for additional accommodation, it can allow for better escape potential, but it can also potentially reduce helicopter flights as well, depending on how you're structuring your rosters. So if you can reduce your helicopter flights straight away, that's the tick in inherently safer design. Because whilst we all accept we need helicopters to get out to our offshore platforms, helicopters are a source of risk. If we can do less of that, then by its very nature, we've reduced the risk because we've reduced the likelihood. We haven't reduced the probability, but we've reduced the likelihood at that point. And so some of these things are the sorts of unusual things that we don't necessarily think about when we're trying to choose the right concept. And that's why we're trying to get people to think about these things a little bit more. And so, as I said, we've actually provided a checklist of examples for people. And then we've actually provided two different examples in it as well. We have provided an offshore example and we've provided an onshore chemical plant example, just to try and show how you might try and apply some of these checklists and think about what you're going to do at that point.
Obviously, it's a moving, growing thing, a living document. So as you're going through these things, some things may apply and some things may not apply. Is it smart to narrow down the process safety focus so you don't have too many things to look at, that you kind of lose sight of the main goal?
You do need to be very careful about that. You need to, the idea of concept select is to narrow down. That's the whole point. You've got a range of options on the table. You narrow it down to one that you can take forward to front-end engineering and design. So the whole concept is to narrow down. So you do need to start eliminating and knocking things out of the options list, absolutely. The challenge that we've then got is making sure when you start to knock things out of the options list from a general engineering perspective, you're not starting to knock out the process safety things that are trying to be put in. But there is a balancing act to be struck here. And I've spoken previously about how inherently safer design is not absolutely safe. Nothing is absolutely safe. We need to weigh up the risks and we need to make decisions based on what is the best option, because it becomes a trade-off. And it's not only the classic trade-off we're used to of finance versus safety. It's not that trade-off that I'm talking about really at this point in time. It's, I could take this option and I might be able to, in the nature of inherently safer design, I might be able to eliminate the use of a flammable substance. And that's fantastic. But all of a sudden, I need to process at very high temperature and very high pressure. Now, that's a hazard as well as flammability. I've taken out one hazard, but I've had to increase the presence of other hazards. What's better or what's worse? And this is a judgment call that needs to be made on an engineering basis. And this is where things like quantitative assessment can help. They can sort of say, okay, if we had this risk, these hazards, here's what the risk is. If we had these hazards, here's what the risk is. Which risk looks better? We can do it that way. But the other part of this concept select phase is typically this is where you're going to go through and you'll need to apply some sort of ranking or rating methodology to make these decisions and start to take options off the table. And we don't talk about the specific ranking methodologies in any great detail in our document because they have all been documented elsewhere. We refer you to a range of different methods that are generally accepted, and in fact it may even actually be your own internal risk matrix and or assessment methodologies that you use. That's the methodology your organisation may choose to use, and that's okay, provided it's thorough. But there's a range of other different ranking methodologies that can be applied at this stage to pick which options might be good ones or perhaps less optimal for you.
With the ranking, so that is the ranking aspect, I understand, but is there anything that you can do to monitor goals or monitor the success of process safety?
Yeah, so you need to actually also, again, with everything to do with safety, we need to be monitoring it and measuring it as we go through. So you need to have appropriate metrics or KPIs as you go through the project from concept select all the way through to operations and eventually decommissioning. You need to have metrics all the way through. The metrics will change. They will vary as they go through. But you need to look at what you can do to monitor what's going on. Though always when I talk metrics, I do give the caution of, remember Goodhart's law, when a measure becomes a target, it ceases to be a good measure. We need to make sure people are actually managing the system, not just managing the measure. It's very tempting to manage the measure to get the result we want, but that doesn't help us manage the system at all. So in terms of some ideas of what you might think about for metrics in this particular stage of a project is, if you've done your review workshops and you've got actions out of them, the closure of those actions, the rate of closure of actions, and also from a quality perspective, did the action that was closed meet the intent that was set at the time? Because often we see actions raised in risk assessments and workshop activities, and it might be the action's poorly worded and it tells us to go and review X, Y, and Z. And so the person that gets the action thinks, right, I've got a lot of work to do, review X, Y, Z. I've looked at it, done, close the action. And I would say, one, that's a poor action, and two, that didn't meet the initial intent, obviously. If they wanted you to review something, there was a reason, and they wanted an output for it, not just a closed action. So look at the quality of what's going on as well. Look at the number of actions that are overdue from those workshops. Review things like the current risk defined, risk tolerance for the project. So what's the current risk that you've got, and what risk was defined by the organisation as acceptable? Where are they sitting with relation to each other? Are they aligned or not? If they're not aligned, you need to think about that and look at whether something needs to be adjusted somewhere along the way. Things like if you've made changes to the inventory of hazardous chemicals from the initial concept. So if the initial concept has said, this is what it's going to look like, and as we go through the project, all of a sudden we're changing, and instead of storing 10 tonnes of a particular product, we're now going to store 1,000 tonnes of that product. Oh, you've just changed the whole concept here. So understanding those changes as the concept is being reviewed and refined as it goes through, and see if anything is being slowly turned back and process safety thoughts are being removed from it at that point. Then what you can do to put it back in. If any of the defined philosophies, like operating philosophy, maintenance philosophy, if any of these change, monitoring the change, looking at the difference and understanding what it means. Because the other thing to remember is that if none of these decisions are discrete and independent of each other, they're made collectively at the time. So in that example of, if you've got 10 tonnes defined initially and you decide you're going to have 1,000, that's obviously a significant change at that point for that substance. But what's interconnected to that? At 10 tonnes, you might not have needed fire protection, but at 1,000 tonnes, the fire protection needs are very different, perhaps. So how's that been factored in? So a lot of the decisions are interconnected, so you really need to understand any change that's been made to the philosophies as you run through this. Do you have the right resourcing and monitoring the resourcing that you have? And how do you manage changes that may trigger a different regulatory approach? So you might have initial approval from the regulators to proceed on something, and then you keep changing it and tweaking it and modifying it. Does it still meet the intent of what the regulators gave you initial approval for? Or do you need to go back again and check some of that? So there are some examples that you could look at in terms of how to follow some of the metrics to see where the project is and how it's tracking.
Obviously, it's not something you can just set and forget. It's not a busy work guidance document. It's something to really get you thinking and really moving forward through and walking through steps and understanding it and going back and forth. Obviously, I'm going to put a link in for this podcast in the transcript so that they can get access to the guidance document. Is there anything you want to add that we didn't touch on?
I think one of the key things to remember is you said it's not set and forget, and it's not. You can put process safety in the concept select phase, and that's where you need to start. But you've got to remember that process safety has to fit in every phase of the project. You can't just put it in at the start and forget it, because not everything you put in will actually be a passive control of some sort. And even the things that are a passive control. So things like a passive control that you may have is the tank bund, for example, because it doesn't need any triggering to perform its job. Its job is to contain in the event of a loss of containment. So you don't need to, there's not an alarm or a switch that makes the bund work. It's there. But it needs to be maintained. It needs to be cleaned out. You need to make sure that it still has its integrity, that any penetrations that have gone through the bund walls have been adequately sealed. And we've seen many incidents over the years where that's an example of a passive control that is not maintained because we actually even forget to see it anymore. It's just there. Things like bunds need routine maintenance applied to them. Are the walls still the same height, or have they started to erode away? And we've seen many incidents occur where bund failures have resulted in making the incident far worse than it needed to be. The one that immediately springs to mind for me is Buncefield, the tank farm in the UK. There were a number of penetrations through the bunds that were not adequately sealed. There was cracking, and the bunds in that instance were unable to hold both the fuel and the firefighting water. So from particularly an environmental impact in that, there was substantial runoff into the local environment from that fire that was quite significant as an environmental impact. Had those bunds been in a better condition, the initial spill might have been better contained and there might have been less runoff. So it's an example of something that's passive that you put in at the very beginning, but you've got to keep a focus on it. And then you've got all your active controls in a process safety sense, and then all your administrative controls, your procedures and your people. How are you continuing to make sure that everything that's being done along the way works and works as you intend it to work, to manage the risk you have on your facility? So my final words for people on this is process safety applies throughout the entire life cycle. There's no point in it where we can set and forget and walk away from it. It requires constant vigilance. The challenge we have is when it works well, nothing goes wrong. And so everybody then starts to say, do we really need to be spending all that money? Because nothing's going wrong. The reason nothing's going wrong is because we're doing it right. Not some magical, well, it's all going right, so we don't need to do anything right. That's not how it works. So we need to have that constant vigilance and keep focus.
Well, Trish, you are always the champion for keeping us focused on process safety, and I'm sure that more than one person has said, what would Trish do in these sorts of circumstances? So you're the little voice, you're the little angel on the shoulder guiding them through, I'm sure. Unfortunate events happen all over the world, and we will be here to discuss and learn from them, and in this case, offer a tool to help mitigate risks. On behalf of Trish, I'm Traci, and this is Process Safety with Trish and Traci.
Stay safe.